All right, 5-minute lessons, multiplying radicals. Okay, like the last one, these get a little bit tougher as we go. Carlin, pick one. We're going to start with number 3. What number 3 is telling you is that you cannot combine a square root with a cube root unless you just make the answer a decimal. So I'm glad you picked number 3. It's a great choice. But let's see what this says. That's radical 3. What's the cube root of 27? Oh, that's just 3. So the simplest way we can write that is 3 radical 3. Okay? Elena, is there one that I can do for you right now? Help you?
I don't know.
Number 5. Okay. Radical 18 times radical 50. The general technique on this is do as much math as you can before you multiply. So do you remember how to simplify radical 18, Elena?
4 radical 2.
Very good, but it's 3 radical 2. So let me explain why. Isn't 18 9 times 2?
Yeah.
What's the square root of 9?
3.
So it's 3 radical 2. Okay? Now, radical 50, we can write that as 25 times 2. What's the square root of 25?
5.
So this is the same thing as 5 radical 2. Now, what I want you to remember is that when you can multiply numbers in any order, it's always been true. So 6 times 5 times 3, that's the same thing as 3 times 5 times 6. Okay, so this, just do 3 times 5 first. What's 3 times 5?
15.
And then it's okay if you don't know this. What's radical 2 times radical 2?
2.
It is 2. It's radical 4, or it's radical 2 squared, which is 2. So the answer to this is just 30. Let's do some harder ones. All right, Carlin picked a good one. We're going to do number 10. Notice this feels a lot like what we did yesterday, which means this must be important and difficult because they're like going back through it. Okay? The cube root of negative 16a to the 12th. Well, first of all, to Rachel's point, it is okay to have a cube root of negatives. It's a cube root. I want you to think about this like the cube root of negative 16 times the cube root of a to the 12th. Okay? All right. I don't know the perfect cubes, so I'm going to write them out. What's 2 cubed? That's right. And 3 cubed? 27. Well, 27 is already too big, but the 8 is going to matter. So I'll rewrite that as the cube root of 8 times negative 3. And so we can write that as 2 times the cube root of negative 3. Or you can write it as negative 2 times the cube root of 3. Both of those are fine. Okay? They're both the same thing. All right, now, what is the cube root of a to the 12th? Well, what thing, when you multiply it by itself, gives you a to the 12th? Well, we can just divide our way back. So it's going to be a to the what? It's going to be a to the 4th. A to the 4th times a to the 4th times a to the 4th equals a to the 12th. So if we take the cube root of a to the 12th, we get that. 12 divided by 3 is 4. One way you can do it. So we're going to rewrite that answer as 2a to the 4th times the cube root of negative 3. Sorry, of negative 2, yes. And then I just cleared it. I have no undo button. So thank you. One more. Let's do one more of these hard ones. Pick one. Elena?
15.
Oh, thanks a lot, Elena. Number 15. All right. It's the 4th root of 625 times the fourth root of u to the fifth times the fourth root of v to the 8. Well, now it's like important that we start like learning from our previous ones. The fourth root of 625, you can put in your calculator. That is 5. When you get to the fourth root of u to the fifth, I want you to think about that as the fourth root of u to the fourth times u to the first. Well, what's the fourth root of u to the fourth? It's just u. Okay? It's all right. You'll get it. You have to practice this and let it sink in. So we're going to rewrite. And then here, let me do this. Do you happen to know what the fourth root of v to the eighth is? It is v to the second. So what you're doing, Elaine, is you're starting to catch on to the pattern. We can use division. 4 divided by 4 is 1. So this is going to be 5 times u to the first times the fourth root of u times v to the second. Well, I'll rewrite that as 5u v squared times the fourth root of u. And I would not get too worked up about this stuff. This stuff is not that important, even though it's complicated. It's not that important. We don't run into it a lot in math. So just get through it and keep working, okay? All right, hope that helps. 5 minutes over. Boom.